The analytics boutiques offer an end-to-end solution for modeling operational risk and stress testing. It incorporates the four data elements: internal loss data, external loss data, scenario analysis, and base, and produces all the metrics for its integration into the management of the institution. It does with all the model governance, including user control, audit trail, integrity of data flows, interfaces, and extensive reporting functionalities. We work with major clients, and we are the provider of modeling solutions for the largest GRC vendors. Op Capital Analytics permits to slice and dice your data with any criteria or field existing in your database. Here we have it in primary cost, but we can have it in business line or any other criteria. Now we have total losses or mean losses by date, or the sigma parameter of the log normal fit, or the phi parameter of the Pareto fit. It also provides with a grid to show the histogram information data, to provide also the audit trail with all the specific filters that have been applied to the data and that has been recorded automatically, and even the underlying detailed data. Op Capital Analytics provides all industry standards for determining the tail weight and optimal threshold, the heel estimator, the DEDH, the stability parameter, the tail plot, the mean excess plot, goodness of fit by threshold, and capital stability by threshold. Op Capital Analytics can fit multiple distributions to internal or external loss data. It provides multiple means to evaluate the goodness of fit, including graphical, such as the histogram and the cumulated distribution function, and the difference by bin, the probability plot, the quantile plot under multiple formats. It also provides multiple numerical goodness of fit, such as the p-value of the Anderson-Darling and the Kolmogorov-Smirnov. Multiple distributions can be represented into the same histogram and be compared along the goodness of fit graphics. Op Capital Analytics permits to evaluate the capital instability of different distributions, different thresholds, and different fitting methods. Scenario analysis modeling starts by the selection of the scenarios provided by the expert. Loss estimate by the scenario can be provided in any format, such as worst loss in 10 years, in 100, and then once selected the scenario, it is sent into the scenario modeling module. Op Capital Analytics permits the modeling of a scenario analysis in much detail. We can provide the loss estimates by specific numbers of years, and distributions are fitted to these results with corresponding graphical means to determine the goodness of fit, and additional to numerical means. In addition, we can add skewness and kurtosis information coming from external data, for instance, and add it as an additional target. We then will fit the distribution to obtain new results. The resulting distribution will reflect not only the percentile from the scenario analysis, but the skewness and kurtosis set as a fitting target. We can also determine stress factors to severity and frequency, and we can then rerun the distribution again to have stress results from a scenario. The new distribution will be reflecting the stress values for a scenario analysis. Op Capital Analytics provides with a very robust hybrid model where information from internal loss data in several segments can be included, also external data and scenario analysis into the same operational risk category. The weight of each data element can be selected based on the segments of the distribution, and there are very detailed ways to define the insurance program. Finally, a Monte Carlo simulation is produced to calculate the VAR at different confidence intervals and slicing and dicing the analysis by business lines or risk types in different graphical representations and tables, and multiple ways to allocate capital based on incremental analysis, Euler allocation, or unexpected loss. We provide multiple ways to create predictive models for identify departments where high losses are more likely, for instance, or where frequency is more likely to increase, loss frequency more likely to increase. Together with the generation of models, we provide multiple means to analyze the goodness of fit that includes all numerical analysis, statistics, and cross-validation very quickly can be generated and identify how models are which are the best models.